So as I said, thank you again for inviting us to present our project. Biogasnet project has been running since September 9, 2019. So it's kind of 3.5 years. So we are now at the last year of the project. So for this presentation, I'm going to give some insight on biogas, biogas production, biogas upgrading, and more precisely, biogas desulfurization using biological technologies. So let's start. Well, as you probably already know, biogas is a renewable energy that is produced from organic wastes. And basically, it is used in this kind of CHP units, the combined heat and power units, to produce electricity and energy. Basically, biogas is a mixture of compounds, of gaseous compounds that basically contains methane. The amount of methane in biogas, it depends on the initial composition of the organic wastes, and also in the treatment or pretreatment of these wastes. Also contains carbon dioxide and some impurities, basically hydrogen, water, and more important for us, these reduced sulfur compounds. Basically, hydrogen sulfide in this 1-3% in volume. This H2S can cause acid rain and also the corrosion of the combustion engines. So it is important to remove this hydrogen sulfide from biogas previous to its use as fuel. Okay, there are lots of technologies to be used to prevent, for instance, the production of H2S, but also, basically they are related to the inhibition of bacteria, which cause the production of this compound. But also, once the H2S is produced, we have lots of technologies already in the market to remove this H2S. But in our case, our research has been focused on the biological technologies. So basically, these biological technologies consist of that the pollutant, in this case H2S, is oxidized by bacteria, which act as catalyzers. This H2S is oxidized to elemental sulfur or sulfate and produce more biomass. And the only need here is an electron acceptor for this oxidation, which is generally either oxygen, air, or a nitrogen compound that can be nitrate or nitrite. Also, the final products are always the same: elemental sulfur or sulfate. But yeah, we also need these are autotrophic bacteria, so we need also CO2. But biogas contains kind of 20-30% of CO2 that we are plenty of it in biogas. So but are really these biological technologies able to desulfurize, to eliminate this H2S from biogas? Okay, typically the biological technologies, by trickling filter and biofilters, are used for this area of low concentrations, high flow rates. Why? Because they are simple technologies. We don't require chemicals added to the system. For this, they are more economical. We produce natural species because they are already oxidized by bacteria, so they are not harmful. And also we can cope with high flow rates. But the main challenge here is that H2S concentration in biogas exceeds the technology limits of biofiltration. So we investigated for I remember 9-10 years in the possibilities to oxidize these high amounts of H2S by both aerobic and anoxic conditions. This means using as final electron acceptor oxygen, let's say air, or using either nitrate or nitrite to produce this oxidation, this partial oxidation to elemental sulfur or complete oxidation to sulfate. The second part is this anoxic oxidation has some advantages because oxygen is quite insoluble, so it's very, very difficult to transfer oxygen from air to water where the bacteria are, oxidizing these H2S. Also, oxygen is a fumburant, so when you store this biogas, this methane, combined with oxygen, this is not a nice idea for the plant operators. They prefer just to have, the fuel in one tank and the carburant in another one. And also, the only drawback of this anoxic oxidation is that we need a nitrogen source. But this problem, this issue can also be an opportunity, and that's why we create this, this project called LIFE Biogasnet, where we are trying to develop a sustainable biogas purification system to be operated in landfills and municipal solid waste treatment plants. This is the website of the project. I mean, you will find here lots of deliverables, videos, social media contacts, lots of information on it. And just I would like to say that the partners of this the project, we are 6 partners. The Technical University of Catalonia, which is the coordinator, also the National Technical University of Athens, a technological center, EURECAT, an engineering company which is called AERIS, and Bioreciclaje de Cádiz, which is the owner of a landfill they are exploiting a landfill in Cádiz, in the south of Spain, and the University of Cádiz as well. The project, as I said, starting in September 2019. The budget of the project was more than 2 million euros and funded 55% from the LIFE project, from the European Union. So the main objective here is to demonstrate the cost-efficient and low carbon footprint technology to upgrade biogas, and more precisely to desulfurize biogas, in order to boost the use of this fuel as a sustainable energy source. So basically, we have been running a prototype. This is a demonstration project. We have been running a prototype for more than 1 year in Cádiz, in this landfill owned by Bioreciclaje. And here the idea was that, look at this, just we use remember that I said that we need a nitrogen source. So in this case, we use the landfill leachate, which is very rich in ammonia, to obtain this nitrate by using a nitrifying bioreactor, and then this nitrate is combined with landfill biogas to produce, basically, we have clean biogas and elemental sulfur as a byproduct, which can be used as a fertilizer or for different industries. So this is, a draft scheme of the prototype, with a nitrifying bioreactor and the bioscrubber, which is the bioreactor we use for the hydrogen sulfide oxidation. So we have thousands and thousands of results and data. Just a brief insight on this. We operated the prototype for 62 weeks, and this is the amount of leachate we treated. So we are at the same time desulfurizing biogas and treating this leachate, which is great for the waste, for the landfill operators. Well, regarding the desulfurization unit, just a few data here. We can reach removal efficiencies close to 98%. This means reducing the H2S content up to 2 ppm. This is very, very low. And this graph, on the right side, is a typical graph we use with biosystems, biofilter, drinking filter, where we show the inlet load, the amount of pollutant we are entering the system, and the elimination capacity. So this diagonal means 100% of removal efficiency. And this data, this average elimination capacity of 8.4 grams of H2S per cubic meter per hour, is a very low value if compared with the data we had in the laboratory, which we reach values higher than 100%. 100 grams of H2S cubic meter per hour. This is caused because the concentration of H2S in that landfill was not so high. So, well, our technology is very, we can use the technology for this case, but we know that we can extend the technology to a more complex biogases. So after that, the prototype was redesigned in Barcelona and then sent to Athens, which is currently operating. In Athens, we have installed the prototype in a facility owned by the Association of Municipalities in the Attica region. In fact, it's the only landfill in Athens, which is treating all the solid wastes of the area of the Attica region. And here we have the prototype split into parts. From one side, we have, in this case, we are using as a nitrogen source exhaust gases from an MBT composting plant. So these exhaust gases contains basically ammonia and VOCs. So we use this ammonia and basically to obtain our nitrate for the project. And then we send this nitrate and nitrite to another part of the landfill where we have the CHP units. This plant is the largest biogas unit, the largest gas cogeneration plant operated in Europe. And we are going to test the technology in these two sites. As I said, in this case, the prototype is split into parts. The first one is this kind of red arrows, where you have the composting exhaust gases, which are absorbed, and then they are nitrified here. This is the nitrifying this is also by a scrubber. And then we use this nitrate, send it to the second part. In this case, this is a biotricking filter, because we want here to completely oxidize. We are completely oxidizing H2S to sulfate, because we want to produce here ammonia sulfate. We are going to absorb much more ammonia, send this to this tank, and then produce the ammonia sulfate, which is also a byproduct we can sell as fertilizer or other aspects. So in brief, this is the idea of the project. Basically, now we have started the operation in Athens. The prototype will be operating here until January 2024, and the project is finishing in March 2024. So yeah, hopefully this is a kind of announcement. We are trying to organize a workshop at the end of 2023 in Barcelona. When I have more details on this, I will just use the social media and mailing, whatever, just to invite all of you to this event. We are still defining the topics. Basically, they will be related to biogas upgrading, but probably we are open to other topics. So I will keep you posted on this. So thank you very much for your attention. That's all from my side.